So what are we talking about? This is, I'm going to call this Chapter 7. Oh, goodness gracious. Chapter 7. This is the integral between curves. Integral between two curves. I say curves, but it doesn't have to be a curve. It could be a line. Curves. And then we'll get into 3D integrals soon. So an integral between two curves, what are we doing here? This is the last topic. It's nothing really new. Again, we're just doing an integral. There's only three. Oh yeah, Perry, so we're going to get three-dimensional here. There's only three pillars of calculus. There's limits, derivatives, and integration. And what we explore is what you can do with these tools. These are the three main tools of calculus. So what can we do with integrals? So far, what we've done, so far, the integral is the area under a graph. Right? So far, we have found the area under a curve, right? So like, here's a function here, right? You go from, let's say, from A to B, and you find all this area. You have like positive area, you've got negative area here, and you've got some more positive area over here, right? That's what we've understood. If we did the integral, oh goodness gracious. If we did the integral from A to B of f of x dx, it would be this thing here, right? The area under the curve, whatever this is. But what I want you to notice here is we use the line y equals 0, or the x-axis, as a kind of floor. We've been doing this the whole time. We didn't really pay attention to it. We're kind of like, oh yeah, of course, that's the bottom. Of course, that's the end, right? That's where the area stops. But there's all this area below here, right? There's all this area below here. We don't really count this, or this area above here. We don't really count that because overall, it all kind of cancels out. If you go to infinity, right, there's like all this extra space that we kind of don't deal with. But we have this sort of barrier here, this floor of the line y equals 0 that we kind of, assume is always the bottom. We've always had this. We haven't really paid attention to why this is the case. It's just always been that way. We've always just assumed, well, this is the bottom. This is where the area stops, right? But it does not have to be like that. It does not have to be like that. What if we have different floors? What if our area had a different floor? Had our area had a different floor? What if our area had a different floor? So for example, let me give you an example here. I want to find the area between the curve y equals x squared and y equals 2x plus 1. In red, do that in blue. Oops. So what we're going to look for is, here's this equation, right? That's y equals x squared. This is x squared. And here's 2x plus 1. Looks like, let's go like this. Like that. 2x plus 1. And x squared is here. So now we have a pair of equations, right? We have this pair of equations, and I want to find the area that is between these. So we really want green. I want this area in here. Right? This is the area we want, the area between. Area between is this area in the green there. So we kind of have like this upper function and this lower function. And we're looking for the area between this. So instead of using the bottom as the x-axis, now our bottom is this x squared equation, right? We're starting up here, we have the area up here, and we kind of have this area underneath here that's sort of like a floor, a new bottom part, a new like area that we're doing between it. Instead of just assuming that it's the x-axis all the time, we now have this other kind of bottom part of our equation. So how does this work? How can we find an integral of this situation, right? So what we're going to do is we're going to say that this. How am I going to draw this? I think I'll do a little. Oops. I'll do a little small drawing over here. What we do is we take the area of. Let me do this better. To find the area between. To find the area between, what we do is we take the area of the upper equation, right? So we take all this area. This is y equals 2x plus 1. We take, that's in blue, all of this area here. Let me draw this in blue, actually. Let me draw this in blue. Do a little bit better. Hold on. Take our blue equation. 2x plus 1, like this. Like this. Y equals 2x plus 1. So we take the 2x plus 1 equation. We have the area under that equation, right? We do the integral from, from some starting point A to some ending point B. Integral from A to B. From A to B of this 2x plus 1. And we have all the area underneath this one. Okay. And then we take the area underneath the x squared equation. X squared. Again, from whatever the a is to whatever the b is. Right? And you do all the area underneath this one. Integral from a to b of this equation. And what you're going to do to find the area under, this between these, is we take this upper area and subtract from the lower area. And that's going to give us this like chunk in between. Let's go like here and like here, right? And it's going to give us, if we do the subtraction, we take all the area above, right, from this upper part. We're going to take away, right, we like remove all this area of the red part below here, and all we're left with is that green section above, right? You see what happened here? If I take away all that area below, if I take away all the area below that, it creates this green chunk. And so to find this green chunk, all we're going to do is we're going to take the integral from a to b of the upper equation minus the lower equation. Or, let me do this. Let me do this the long way. The integral of, I'm going to do 2x plus 1 minus x squared dx. So I just take my two integrals and I subtract them inside one big integral. I just have a subtraction. I just take my upper function, the higher function, minus the lower function, and I create my equation And now this is just one big equation. I've created this kind of hybrid equation that gives me the ability to find this area between two other equations. It's a function, this is negative x squared plus 2x plus 1. It's a whole new equation. And I just now have to take the integral of this new equation, just like I've done every other integral before. So I'm just taking my equations, I'm combining them by subtracting the upper one minus the lower one, and I'm creating this new equation that gives me this area between them. So the area between is equal to the integral from a to b, some starting point, some ending point, of the upper function, upper, minus lower dx. And that's how we can find the areas between these curves. Okay. So let's do an example here. Let's do, what's a good example here? That's kind of boring. All right, here's an example. Find the area between these equations here. Y equals x squared plus 2. Y equals negative x. X equals negative 1. And x equals 4. Let's find the area between these sections here. So I have 4 equations. So first thing I want to do is draw it out. First thing I want to do is draw this out. So what's this graph going to look like? Let's do a red here, blue here, and then these will be green. First thing I want to do is draw this equation, draw this out. So I know what I'm looking at, so I know which one is the upper equation, which one's the lower, where the starting point is, where the ending point is, how this all works, right? So y equals x squared plus 2. I know I start at 2. I go over 1 up 1, over 1 up 1, over 2 up 1, 2, 3, 4, over 3 up 4, 5, 6, 7, 8, 9, up to like here or something. And it's like this and like this. So just getting a general picture I have looks like, well, good enough. Looks like that. I can do better. Looks like, whoop, well, that's fine. Looks like that. All right, so that's my x squared equation. The y equals negative x equation starts here, goes down and up to here and up to, right? And then down to here. So it looks kind of like this. This is my y equals x, right? So they don't cross anywhere. So I don't have like a region contained by these equations, but I have these other two lines, y equals x equals negative 1 and x equals 4. So those lines, well, these are x equals lines. Here's negative 1, here's 4, right? Let me make this 3. Make this 3. 4 is too much. Make this 3. I'll make it 3. So the regions of x equals 1 and x equals 3, that's this vertical line here and this vertical line here. And so now the region I'm talking about is everything in here. All of this stuff in this zone here. This is my area that I'm looking for. All this area in here. Try to do this a little bit better. Right, so this is my area in here. So how would we find this area? So there's a couple things to note about this. A couple things that are important sort of features. Some area is above, and some area is below the x-axis, right? So we have this area that's above the x-axis, we have some of this area that's below the x-axis. And that's okay. The beautiful thing about doing this process is we don't really have to worry about area above or area below. Because when you subtract the lower one, it kind of works itself out. It knows that it's negative area, and so you have this space between you. The equation understands what this area between these spaces are. We're just finding the total area. We're not really concerned about positive, negative. So we're not really worried anymore about area above or area below. It's not a concern. Not a concern with area between curves. Okay? That's not really a concern with area between the curves. We don't have to worry about positive area or negative area. The equations and the subtraction takes care of everything like that. So the next thing we're going to do is set up the integral. Step 1, find start and the end point. So where does your integration start and end? Sometimes this is complicated because you have to find out, for example, where the two lines intersect, like here and here. Sometimes you have to find out where the two lines intersect and use that as your start and end point. So sometimes that's a challenge, right? Just a little note here. Sometimes you have to find where the graphs, the functions, intersect. And so you set one function equal to the other function and solve. To find out where they intersect, you have to set the two equations equal to each other and then solve, right? That's how you find intersection points. Make the two graphs equal. Where are they equal? Where do they intersect? So sometimes you need to find those intersection points on your own. Sometimes the start and end points are given. Like in this case, we have x equals -1 and x equals 3. This is our start. This is our end. So sometimes they tell you where the graphs begin and end. Other times it's obvious from the intersection points. But you have all these possibilities for finding the starting and end point. So you do a little graph, see where they intersect. And once you have a start and end point, you set up your integral. Step 2, set oh goodness gracious. Set up the integral where you do the upper minus the lower. This says upper. The upper equation minus the lower equation dx. And so for this upper-lower, you just look at the graphs and you look at which one's the higher one, which one's the lower one. So here it's x squared plus 2 on top minus negative x on the bottom. So our integral is going to be the integral from negative 1 to 3 of x squared plus 2 minus negative x dx. And then step 3, solve. All right. So we got our graph. Got our graph here. Looking at these functions, right? Picturing what this looks like. Draw the graph. Notice where your start endpoint is. Look at the area. Shade in that area. Set up your integral by finding out what the upper equation is minus the lower equation. Here it's x squared plus 2 minus negative x, so that's going to be plus x, right? And then solve it. So when I solve, oh goodness gracious, let's go back down here. When I solve, I'm going to have the integral from negative 1 to 3 of x squared plus x plus 2 dx, right? Because I simplified. Right, my minus minus here becomes a plus, a positive. And I rearranged it to be all together. And, you know, I can do this by hand or plug into a calculator. Specifically, the Desmos calculator. If you have not used it yet, very handy feature. Let me go here, and let me do this. To get the integral, by the way, you type INT. Look at that, what he sets up. INT, integral, from negative 1 up to 3 of, and then write your equation here. X squared plus x plus 2 dx. 21 and a third. There's your answer, everybody. 21.3 repeating. So that's our answer here. We get the area equals 21 and 1/3 units. Right? Desmos, very useful feature. We could even look at this if you want on Desmos, right? X squared plus 2, there's one equation. I've got negative x, there's the other. I've got x equals x equals negative 1, and I've got x equals 3. So there's my graph. I have my upper, my lower, my area between. And find that area in my curve. Questions, everybody? How close did I get? Let's see, where's my graph? Oh, no, stop it. I think I did a pretty good job. That was pretty close. All right. Should we try another? What about a more complicated question that requires us to solve for intersection points? Like one that's little more complicated. Let's see. How do we do a little more complicated question that requires intersection points? Another example. Find the area, they use this term often, bounded, like contained by. The equations right here. X squared plus 2x plus 1 and y equals 2x plus 5. Find the area bounded by these two equations. I'll give you a big hint, everyone. Why solve it on your own? We have the technology, just friggin' use it. Graph these equations on Desmos. Desmos will tell you exactly where the start and end points are, where the intersections are, and you can, I don't know, go do other things with your plug these into it. Let's plug them into Desmos, everyone. Why do anything else? Cancel all this stuff. Let's get our equations here. X squared plus 2x plus 1. Y equals x squared plus 2x plus 1. There's one equation. 2x plus 5. Y equals 2x plus 5. There's my second equation. Look at this, everybody. My starting point is -2. My ending point is +2. There are my bounds of integration. I know that my graph is going to start at -2 and my integral rather, and end at +2. And that's all the area between here. And my upper one is this, upper, and my lower one is this. So my integral is going to be from -2 to +2 of, let's do a square bracket here, of 2x plus 5 minus x squared plus 2x plus 1. Now, let me do this in my board here. Hold on. So let's do it here. So when I graphed it, let's draw a little graph now. We had one equation that looked like, let me look at my picture. One equation looked like that. One was like this, and the other was like this. And it went from -2 to +2. And I want to find this area here. So do my little drawing, shade my little area that I'm looking for, find my bounds of my integration, and I know it's going to be from -2 to +2. What did I say? Of 2x plus 5 is the upper one, minus x squared plus 2x plus 1 is the lower one, dx. If I simplify this, go over here, simplify this, I'm going to distribute this minus sign, minus here, minus here, minus here. 2x and minus 2x are going to go away. Now let me lay this out more cleanly. Integral from -2 to 2 of 2x plus 5 minus x squared minus 2x minus 1. 2x and 2x are going to go away. I'm going to get the integral from -2 to 2 of -x squared, and then 5 minus 1 is +4. So you see I simplify, and I can plug into Desmos. Or I can just plug in the original equation in Desmos. That's all fine too. Let's do that. Integral from -2 to 2 of 2x plus 5, and then in bigger brackets, minus x squared plus 2x plus 1, bracket dx. One element list. What? Oh, no. Maybe I gotta use, I gotta use parentheses. Okay, fine. Use parentheses, everybody. It doesn't like brackets. 10 and 2/3. 10.6 repeating, 10 and 2/3. This equals 10 and 2/3. There's your answer. Should we try the other one? Negative x squared plus 4. If I do the same thing, integral from negative 2 to 2 of x, negative x squared plus 4 dx. Same thing, look at that. Yes, this is exactly what you would do on the AP test. You would use Desmos absolutely, positively, for sure. Of course, keep in mind, like, if you have two computers open, you can do Desmos on the computer. But when you're taking the test, the computer you're using will be locked. You will not be able to go on any other site or place. So if you have another computer, you can use that, or download Desmos on your phones, everybody. Although, yes, that is correct, Jose. Hey, speaking of, they opened up the vaccination site at Jeff for people younger than between 12 and 18. Well, anyone above 12. So if you have any younger brothers or sisters, everybody, younger family, cousins, whatever, let them know. Vaccines open at Jefferson High School from anyone over 12. So get your equations, get your area, find the zone here, graph it in Desmos, tell me what it looks like. So here's what I want you to do to practice this. You're going to do the same thing that we did here. I want you to look at the equations that they give you, find the bounds. I want you to draw the picture, use Desmos to lay out the equations. That whatever they give you in the book, I'm going to give you some questions out of the book. Lay out the equations in the book, draw them on your page, show me the area that you're finding, like shade it in, write the equation, and then tell me the answer by plugging it into Desmos. Just plug it into Desmos, everyone. And this is your assignment for today. All right? So your homework, let me give you this. And this is just the beginning, everyone. It's going to be page 450. I want you to do numbers 15 through 27 odd. Use Desmos. I want you to draw the graph. Draw the graph. Draw a graph. Write the integral. Use Desmos to solve. So that's like, I don't know, 6 questions, 7 questions? So this is our last topic on the AP test. We're going to start here, and then we're going to do some more interesting things with 3 dimensions from this starting point. So we'll do that next class, everyone. Start working in 3D. So again, I'm going to turn in final grades this evening. Make sure you get that test into me, your final exam. I'm going to put all the extra Khan Academy assignments in there. And your grade can only go up from here. So the more things you turn in, I will submit final grades on the last day of school. So we'll continue to finish up our stuff and practice. Again, there's going to be a practice session for AP test tomorrow. I will see you all there. Otherwise, that's it, everyone. Thank you very much. Say goodbye in the chat. Once you say goodbye, you're free to go. Have a wonderful day. Get those vaccines. And I'll see you next time.